fluctuation. So you say, this is my peak. Because if you have a capability that is less than the peak, then when the peak happens, then you have a blackout, which is something that is a disaster. Okay? Now, with smart grid, there's actually the possibility of something called demand response. What that means is, I will try to generate electricity not at the peak, but closer to the average. Okay? So instead of generating here, or instead of having capability here, I have capability here, which is closer to the average. Now the problem is when you're closer to the average, there's a higher possibility that the peak will happen, and then you will shoot above your generating capability. Now, as I said in the past, that's a disaster. With smart grid, what I can do is I can just turn off part of the supply. So basically, beforehand, I would negotiate special arrangement with some major users. And I'll tell him that, okay, instead of charging you $1 a kilowatt hour, I will charge you 80 cents a kilowatt hour. But with that, you have to allow me to turn off your electricity or reduce your electricity, let's say by 10%, one time a month or something like that. Okay? So what that means is with that capability, it's possible for you to reduce your generating capacity without causing a disaster. And smart grid allows you to do that too.
One very last question for you. One very last quick question for you. Do you see any opportunities for entrepreneurs and investors in the smart grid area? Don't you think this industry of smart grid is only an opportunity for the very big players, and small entrepreneurs or small or investors will rely too much on the very big customers, such as the government electricity companies and very large private companies? Is there really some opportunities in smart grid for R&D and for entrepreneurs?
Well, for R&D, yes. As you can see, at Hong Kong, you have a lot of projects going on. For small entrepreneurs, the home energy management system, for which we have already built a prototype, there are some companies interested in licensing our technology to make that equipment. And that project actually does not involve too many people. It's only a few people. So a small entrepreneur, a small company can attack that kind of a problem. If you want to build the big transformers and things like that, probably you need to have a big company. But one of the nice things about smart grid is that there are a lot of internet technology projects. And as is already demonstrated by people like Bill Gates, when you have internet technology projects, you can start at your garage. So basically, it's possible for you to build software and to build algorithms that can be very effective in controlling the distribution of electricity.
Thank you, Professor. We'll forward with our next speaker. Dr. Tsang, if you'd like to join us for your presentation. And we get your presentation on the screen very soon. So Dr. Tsang, please come. You're with... I'll let you do you introduce yourself and do your presentation. Thank you.
Thank you for allowing me to introduce myself. I'm Kev Chung, my name, from City University of Hong Kong. And just like Professor Lee, I'm also working on the smart metering. In fact, which is under the Smart Grid Initiative. This is one of the big initiatives under Smart Grid. And incidentally, I'm also working heavily along city. And anyway, I'm going to brief you what I have done. Next, please. This is the agenda. Since Patrick has talked about the basics, so I won't tell you a lot on this, and I will tell you my experience in the smart metering using Zigbee as well, and I will tell you my study afterward and conclusion at the end. Next. This is only for starting. Everybody knows about global warming, and one of the basic major causes is from greenhouse gases like CO2. So you have the ice melting and water sea level rising, and likely Shanghai may be submerged into the sea very soon. And in 20 years' time, we may have no winter. People said that, and I believe so. And this is also about CO2 emissions. So next. And so let's take a look at the emissions in Hong Kong. If you take a look at all this bar chart, you will see most of the emissions come from buildings, apart from some others from transport and industrial waste and agriculture. About 60% come from buildings, 60% here. Okay, so by buildings meaning you turn on your lightings, you turn on, in particular, air conditioners, and of course in winter you turn on your heaters as well. So that causes the electricity consumption, which in turn will release carbon into the atmosphere. Next, please. And in line with one of the biggest utility in Hong Kong, they would like to reduce the carbon release from 0.8 kilogram per kilowatt hour from 2010 to 0.2 kilogram per kilowatt hour in 2050. This is the AMR versus AMI. By AMR on top left-hand corner, meaning automatic meter reading, in short AMR. In that, most of meter reading will be transmitted back to the back-end server of the utility once or twice per day. So the frequency of the data transmission is much less. Whereas in recent days, in the recent 1 or 2 years, people are talking about AMI, full name Advanced Metering Infrastructure. In that, the data will be two ways. And this AMI will transmit data over command, because sometimes you may wish, as Professor Lee has just mentioned, you may wish to turn on or turn off the actuators. And in line with this, you may need GPRS infrastructure to convey to carry the data back to the backend server. And I will talk about this later on. So next. And just a little bit about AMI. Advanced Metering Infrastructure measures, collects, and analyzes data consumption from advanced devices such as meters, gas meters, water meters, etc. Upon request or predefined schedule via various communication links. Next. I just mentioned we need bi-directional communications, and that makes things much more difficult, and I will tell you more. And the utility collects and distributes real-time, or close to real-time energy consumption information to customers. This is very difficult at the moment. Before AMI is used, the data cannot be real-time. Normally, you look at the data 1 day before at least. And with the capability of AMI, users can audit energy as well as manage the energy. Next. Professor Lee also talked about demand-side management, demand response, in short DSM, that monitors and modifies customers' usage pattern of electricity. There may be debate about this, but I'm not going to discuss this tonight. And DSM includes energy profile, conservation, peak demand reduction, just Professor Lee just talked about, demand relocation and control and low growth. And AMI in this way is the key to provide interactive communication for DSM. Yes, please. So we need demand response and energy conservation for home as well as office and building automation systems. Of course, we can have a lot of technology platforms like power line, wireline, wires, and wireless. And personally, I choose wireless and so is Professor Lee, because we need speed. Because on power line, I've done some study before together with S3, and I found that the speed is the problem on power line. In fact, in Hong Kong, I talked to the utility before. It was never in the past that they did any project using power line. real project, I mean. And reliability, we need to talk about, and scalability, this is the most important part, because sometimes you have some devices at home, you have some devices in the building, but then you may wish to expand, or sometimes you would like to reduce. And by using wireless, this is possible. And readiness of deployment. So is it ready? So it really depends on who is making it. Next, please. Potentially, there are several wireless technologies that are capable, including Wi-Fi, Bluetooth, and Zigbee. But these two provide no mesh. They don't provide mesh technology, mesh capability. Next, please. By mesh, it means if, for example, there's a light switch somewhere, perhaps here, one over there, one over there. If you would like to transmit the signal from here to a very far end, probably you don't have sufficient power. Then you hope from one node, for example, one switch, we say one node, one switch, hook it to another switch, another node B, and then C, and then until the very end, hoping. You don't need a very high power to transmit just one hop, no need. But instead, you can use many hops. And if one of the nodes in between fails to transmit or retransmit the packets, then you may make use of another node somewhere nearby. And then from there, and route it to the very back end. So this is meshing. And the reason to choose Zigbee, like Professor Lee, personally, because this is the open standard based on IEEE 802.15.4, which is, this is MAC layer. And Zigbee has already been widely adopted in both USA and Europe as an open standard for smart grid. And by using this wireless technology, we can control as well as monitor the energy usage at home and at office. And by managing the energy, we can minimize our cost, which means money. And of course, minimizing energy also means less CO2 being released to the atmosphere. Professor Lee also talked about home area network, and I'm also talking about this here. Next, please. Now this is a full picture of under the smart grid initiative, in which you have the HANS home area network, which consists of the, for example, in-home display, lightings, dimmers, power outlet, somewhere down there, power plug, etc., or air conditioners, etc. You also will have the smart appliance initiative under smart grid, in which you may control and monitor the energy of a freezer, a fridge, or heater, air conditioners. This is another initiative. And the third initiative will be the EV charger, which is becoming more and more popular. And as well as the renewable energy like wind and solar. And of course, if you talk about the control, the communication link, you also need some remote method to control as well as communicate. This includes the internet or GPRS or PSTN as well. So there are lots of stuff in here. And today I would like to focus on HANS. Next, please. There were research before, like in Japan and in Sweden. They all talk about human behavior might give 10% to 20% of energy reduction. Next, please. And because I just mentioned that I would like to talk about HANS here, because I've done some project in Hong Kong. What is involved in the HANS are in-home display, light switches, power outlet, and other, for example, Zigbee to infrared devices. By using all these devices, which I will talk about, the tiny energy consumption and pricing information can be provided to users at any time, okay? And possibly at any place, because you have internet connection. Next, please. by using, I just mentioned about all these devices. These are all those devices that I have done technology transfer from CTU to outsiders in the industry in Hong Kong, including power plug, adapters which can be reshuffled around, remote controller, different kinds, touchscreen, and Zigbee to Interact converter, and in-home display. All these have been used in utility in Hong Kong, the biggest utility in Hong Kong. And with this, you can achieve energy management, savings, and others. Next, please. This AMI based on Zigbee, so I call it ZAMI, is divided into two parts. And because I'm using it for AMI, so there's a backbone. There's a backbone basically constituting the vertical part, which in the high rises. And there's a mesh network, which I just mentioned, for the HARNS service. I repeat, HARNS referring to those dimmers, light switches, wall outlet, etc. And the in-home display is a basic components, essential components at home, so that so the users can instantly just pressing a button and acquire the energy information of his usage at the premises. And of course, you have to make this meter smart, and I will tell you how soon. This is one of the display I transferred to the industry, which can indicate the energy usage as well as the data. Of course, by incorporating more sensors into the in-home display, you can have temperature information as well as humidity information, plus others as well. Next, please. Of course, I can also have the device energy consumption being displayed here per hour, on a per hour basis, or per month basis, or per year basis. Okay. These are some of my other work that I can display all this energy consumption per hour or per month or whatever of a particular device on an iPad or an iPhone or an Android platform. You just plot it into the platform you want. Next, please. By using this concept, literally, I can sort out all the energy usage in different parts in the houses or office. For example, this one, socket 1, 2, and light switch 1, 2, may be in the master bedroom, and socket 3, 4, light switches 3 and 4, maybe in the living room. So we can audit the energy at different parts. So you just, that means really break down the energy consumption at every corner. So by then, the parents may know about, the time the children spend on watching TV, etc. Or the usage or the energy consumption, the heavy energy consumption due to, of the air conditioner is due to the kids, but not the maids. So that relieve the maid from being complained by the parents. Please. And this is one of my other projects for one of the biggest utility in Hong Kong, the power plant, one of the power plant, the showroom. Inside the showroom, you see a few devices here. This is the display that I transferred to the industry. This is a thermostat, which I haven't shown in that picture, which can control the temperature as well as the speed, the speed of the, the fan speed. And this is a centralized system. And all these are Zigbee. And this is a Zigbee curtain controller that can turn on or turn off the drips. And this key provides different mood, mood 1, mood 2, mood 3. For example, mood 1 meaning AV mode, the projector will be switched on, and the projector will come down, and the dimmer will, all the dimmers will dim down to a certain percentage, and the curtain will be closed, and others, depending on how you configure the mood. Next, please. And this is the portal that I built for this utility that can read the energy of all the devices and control as well, and forecast. I haven't shown it here. We can do the energy forecasting, and right now this is already being exhibited in the showroom of the utility. Next, please. Next, please. And I was talking about AMI. So harness is only one part of it because normally that happens in the premises like this, or a home or an office. And but in a building there's an